Hello everyone. Welcome to the mini lecture on electromechanical control technology. In this lesson, we will focus on the working principle of the semi-closed loop control system and explore how this control system works in real-world applications. We hope that through this lesson, you will gain a deeper understanding of the working principle of the semi-closed loop control system. Additionally, we will reflect on the profound meaning of craftsmanship in the field of technology. Our lesson will cover the following 4 main topics. Through this lesson, we hope you will be able to understand and describe the basic components and functions of the semi-closed loop control system. Analyze and explain the working principle of the semi-closed loop control system. Deeply understand the important role and significance of craftsmanship in scientific research, system design, and optimization. Before we dive into the working principle of the semi-closed loop control system, let's briefly review its definition. The semi-closed loop control system is a control system that lies between open-loop and closed-loop systems. It combines the simplicity of open-loop systems with the feedback mechanism of closed-loop systems to achieve more precise control. Semi-closed loop control systems play a crucial role in industrial production, automation equipment, and precision manufacturing, among other fields. 1. Key components of the semi-closed loop control system. The semi-closed loop control system is composed of the following key elements. 1. Controller. The controller receives the input signal, such as the target value or set point, and calculates the corresponding control signal based on its internal algorithms. This process requires engineers to have a deep understanding of the algorithm and carefully adjust each parameter, embodying the spirit of craftsmanship in the pursuit of excellence. 2. Actuator. The actuator receives the control signal from the controller and converts it into physical action or response to drive the controlled object. 3. Sensor. The sensor monitors part of the state or output of the controlled object in real time and feeds this information back to the controller. 4. Feedback loop. The feedback loop transmits the sensor's output signal back to the controller, allowing it to adjust based on the actual state of the controlled object. 2. Principle of semi-closed loop control system. 1. Receiving input signal. First, the controller receives an input signal from either an external or internal source. These signals typically represent the desired state or output value of the controlled object. 2. Control signal calculation. Based on the input signal and its internal algorithms, the controller calculates the corresponding control signal. This control signal is sent to the actuator to drive the controlled object to respond. 3. Actuator action. The actuator receives the control signal and converts it into a physical action or response, e.g., the rotation of a motor, the extension of a hydraulic cylinder, etc., driving the controlled object toward the target state. 4. Partial state monitoring. Simultaneously, the sensor monitors the controlled object's state or output in real time, including parameters such as position, speed, and temperature. 5. Feedback signal transmission. The sensor transmits the monitored state information through the feedback loop back to the controller. The controller uses this information to evaluate the difference between the actual state and the target state of the controlled object. 6. Control signal adjustment. Based on the feedback signal, the controller may adjust the control signal. This adjustment is aimed at minimizing the difference between the actual state and the target state to improve the system's accuracy and stability. 3. Working process example of semi-closed loop control system. To better understand the working principle of the semi-closed loop control system, let's look at a specific example. Consider a semi-closed loop CNC machine system. In this system, the controller receives the toolpath information from the CAD/CAM software as the input signal. Then, the controller calculates the corresponding control signal to drive the machine's motors and hydraulic cylinders to move. at the same time. The sensor monitors the position and speed of the tool in real time and feeds this information back to the controller. The controller adjusts the control signal based on the feedback to ensure the tool moves according to the predetermined path and speed. 4. Characteristics and limitations of the semi-closed loop control system. The semi-closed loop control system has several notable advantages, such as improving control accuracy, reducing costs, and enhancing stability. However, it also faces some challenges, such as the need for sensor accuracy and reliability, feedback loop delays, and increased system complexity. To fully leverage the advantages of the semi-closed loop control system and overcome its challenges, careful system design and optimization are required. In this process, the continuous innovation, pursuit of excellence, and holistic thinking embodied in the spirit of craftsmanship will offer valuable insights and guidance. For example, through continuous experimentation and adjustment, engineers can precisely match sensors with controllers, minimizing feedback delays, thus making the semi-closed loop system more refined. Today, we have explored the working principle of the semi-closed loop control system, learned about its key components and functions, and grasped the method for analyzing its control principle. We also recognized the advantages and challenges of the semi-closed loop control system in industrial automation. By adopting partial feedback signals, it has certain anti-interference capabilities and offers more precision than an open-loop system. We also deeply understood the important role of craftsmanship in scientific research, system design, and optimization. We hope that in your future studies and work, you will continue to embody the spirit of craftsmanship, pursue excellence, and contribute to technological progress and social development. Lastly, please think about this lesson and complete the following exercises to consolidate today's knowledge points and deepen your understanding. That concludes our lesson for today. See you in the next lesson.